Hello, everyone. Thank you so much for attending today's webinar. This will be about accelerating manufacturing supply chains with TigerGraph and Expero. Before we get started, I just wanted to go over a few items with you all. Just so you know, there will be time at the end for Q&A. So if you have any questions, please feel free to leave them in the Q&A box at the bottom of your screen, or message me, the host, Expero Internal, and I'll be happy to get the questions answered as well. Just so you know, we are recording today's session, and I'll be sending out a follow-up email with the recording. It'll also be hosted on both of our websites. And if you have any questions or issues during the webinar, please message me, and I will be happy to assist. And it looks like everybody can see the screen now. So I will go ahead and turn this over to our team of panelists.
Thank you so much. My name is Michael Shaler. I run partnerships for TigerGraph. I'm here today with Scott Heath, who is the CRO for Expero, along with Graham Gansley, who's the head of data science for Expero as well. We're so delighted to be able to share with you, a discussion today of kind of how supply chain is a powerful story, and our TigerGraph supply chain platform product really makes a difference here. So we have our three speakers. I'm going to kick things off, and then I'm going to hand it off to Graham shortly. So first, I'm going to talk about the complexity and the state of the supply chain. Then we'll hand it over to Graham to talk about the role of machine learning, graph, and humans. Humans in the loop are still vitally important for machine learning and graph and for supply chain. And then finally, Scott's going to talk about the art of the possible and show us in a demo what is the new Tiger supply chain solution. And we're going to talk about how our joint solution addresses these demos. So we're looking forward to digging in. Next one. We're going to talk first about one of our heroes. Harry Powell is Director of Data and Analytics at Jaguar Land Rover. 3 years ago, they were up against an existential crisis. They were losing hundreds of millions of pounds a year on supply chain penalties to their suppliers. So Harry, has two brilliant quotes. He's quite the raconteur. What strikes me about this is that technology has finally gotten to a place where we can actually support complex optimizations like supply chain. So Harry, his first quote says, for 20 odd years we were told we couldn't even ask these questions about the supply chain. Now we can answer them now. The answers from our supply chain digital twin have delivered over 100 million pounds in incremental profit to the firm. That's kind of a reversal of looking at supply chain as strictly a cost. It's an opportunity for not just saving money and protecting money, but also making money. And then Harry goes on to say, in the before times, we had to ask tortured questions of tortured data, and from such tortured questions, how can we get anything but tortured and therefore ineffective answers? Graph analytics transformed our approach for solving for supply chain. So Harry actually, has been a TigerGraph customer for about 1.5 years, and really, kind of as he says, he has come a long way with graph analytics. But let's go to the next slide and talk about the bigger picture. Let's zoom out for a second. The real challenge, in terms of everything we're seeing in 2021, with all of the myriad challenges, the myriad obstacles, and the myriad strains that supply chains are under, it boils down to a very, very fundamental issue of chronic lack of visibility. The vast majority of companies lack complete visibility into their supply chains. Harry talked about, how they're flying blind 89 days a quarter at Jaguar Land Rover. And then 78% say they lack proactive response. And then finally, they have inadequate visibility into production operations. So there's just a preponderance of lack of visibility, and all the consequences of that are very, very challenging. So let's talk about what is a supply chain and logistics full life cycle. Start from source to manufacturing to inventory to logistics to transport. One of the things that typifies the modern or evolving supply chain is how much of this is moving into the digital realm. Digital transformation really does make a huge difference in supply chain. That means we can meter everything throughout all stages with Internet of Things. Demand and supply planning is going to be critical, inventory management even so. And then for predictive analytics, machine learning and AI is going to be really a compelling story there as well. And Graham's going to go deep on that. Then obviously we have all the routing, scheduling, fulfillment, and risk reduction. And again, more predictive analytics and prescriptive analytics in the supply chains can make a huge difference. Next slide is all about kind of how McKinsey looks at, the digital supply chain and how supply chain 4.0 delivers four areas of six main value drivers, from planning to physical flow to performance management, order management, collaboration, and overall strategy. And you can see that, there are contending forces in terms of the, service, required, the capital required, and then the overall cost from an operational perspective. And hopefully agility will help. One of the things that helps even more than just this high level approach is how graph analytics can change the business value equation for supply chain. It's supply chain management and planning in particular. We're going to go deep on the planning side, but we also add value in terms of performance management, order management, collaboration, and strategy. So we're really excited to see that, again, McKinsey highlights, in a highly idealized model of what all the, challenges of a supply chain might entail. But this model helps us structure the next set of conversations we want to have with customers. Next slide, please. In that context, Gartner sees supply chain as very much a graph-shaped problem, and they've identified among the top 10 trends in data analytics for this year is that graph relates everything. As one of our other customers said, it eliminates the hairball, and we can see into it, and we can actually take action in real time because graph relates everything. If we go down the next slide, let's double click one further. When we think about the 6 kinds of graph analytics, they all apply to supply chain 4.0 in terms of path graph analytics or path graph algorithms, finding the optimal paths. Community helps us identify clusters. Where are my hotspots? Where are my bottlenecks? Centricity, takes that concept even further and identifies which areas of pain are greatest. In terms of similarity, we can actually, evaluate different suppliers, different vendors, and different outcomes, and then we can, run what-if scenarios against each other. We can also find link prediction, understanding how, connections might either form or break, and then connectivity is going to be critical because this is all connected data. Supply chain talks about goods and services moving through time and space, where with, differential value and differential outcomes. And that's why graph analytics is so powerful. It helps, connect all these dots in a very comprehensive way. Next slide. If we drill down on use cases, we can actually talk about, the different business cases in terms of entity relationship, source of material management, material flow, optimization, and a big one is bottleneck detection. How do we know where we really are being throttled by the supply chain? And then we have the optimization and logistics and asset management and IoT and all the rest from a business case perspective. In terms of solution pieces, we can deploy both on cloud and on-prem. We have complex visualization. We can understand dependencies, pathing, routing, and we can understand also the root cause and investigations. We can map these networks in geospatial. We can actually leverage feeds from various IoT systems, and we can do dynamic routing. And then Graham's going to talk about the machine learning analytics in detail here, but the ability to do predictive analytics, do what if planning and visibility, and then being able to have a historical audit and compliance log is vitally important here. And then finally, we can also help with decision tree analytics. Graph can do so much for supply chain. Let's dig in deeper in terms of how that could be a deeply dependent knowledge graph. We have on the bill of materials side, we have nodes that are parts make assemblies, which then become products, and then we can understand the relationships between them, and then we can also understand from an analytics perspective how to get alternative sourcing or prediction of need or cost optimization. From a manufacturing perspective, we have nodes and relationships and analytics again, but this applies to factories, warehouses, disti centers, transport options, how to deal with customs, and how to deal with customers as well. From a critical path perspective, that path that traverses all this, and where is the cliff? Where are the bottlenecks? Impact analysis is all about that. And then optimization is a critical function of what a graph algorithm can do for supply chains. And then finally, on the transport side, we have all the nodes of customers, data centers, distribution centers, warehouses. And then we have relationships to rails, road, and trains, planes, and automobile. And then we have analytics that help us find shortest path, best extensions, and cost optimization. So now let's talk about, kind of we laid the land of kind of how complex and how messy these can be. But when we add graph to it, TigerGraph is the only scalable graph database for the enterprise. And we can help solve some problems that are unique to the graph set of solutions we're working with. TigerGraph's been in business since 2012. We were in stealth mode for 5 years. We're headquartered in Silicon Valley. And we actually are, if you have to boil it all down, the fact that we can actually do graph queries and graph analytics with our G-SQL language is very, very powerful. We can deploy anywhere. We're around the globe. We're foundational to AI and machine learning systems. And supply chain challenges span all of these different vertical markets. And we're so pleased to be able to work with our customers and support, where we're going in the industry together. Next slide, please. Forrester has identified us as a leader in graph, and we're the smallest, youngest company in this chart. And we're really grateful that Forrester said that we're doing so well. What really blows me away on the next slide is kind of how we got perfect scores on scalability, performance, workloads, transactions, queries and search, data loading, ingestion, and our API and extensibility. And our toolkit for supply chain makes extensive use of our APIs and extends it into legacy systems as well as the graph, and then the visualization and machine learning and AI on top of that. So now let's dig into let's revisit Jaguar Land Rover. Next slide. We've already talked about what Harry's journey looked like, but step one was how they got there. We have a great case study. We'll send this link out afterwards, but basically, for starters, they had to get end-to-end data visibility, and they were losing hundreds of millions of dollars a year because they had variations, and then they also had supplier penalties. And so anytime that they can avoid downtime, they're saving themselves $22,000 per minute of downtime. That's quite the SLA. And then the last step is to optimize for profit, risk, and agility. And so Jaguar Land Rover is really at the center of that McKinsey chart we showed before. They really are focusing on how to generate future state scenarios and get the right answer before it becomes critical. So next slide. Gartner also did an analysis or a case study from on Jaguar Land Rover, and they actually talked about what the relationship is between supply and demand. And as you can see in the middle, this is all a graph-shaped problem. So let's work from the bottom on the way up. So we have various suppliers in various locations with various constraints and various advantages, maybe from a cost perspective, availability perspective, but being able to translate that into parts means that the componentry was acquired from the supplier, and they're able to actually put it into the sales board and start to identify where the parts would show up in features inside the car. And so the summary here is the car is the highest unit of integration and assembly. But underneath that, we have features and parts that make that up. And all of that has constraints, they're connected, and we're looking for outcomes to optimize for this. Let's go to the next slide and talk about what that looks like. We're really, we've been able to solve an intractable optimization problem here. And if you change a given feature, let's just take the example of Jaguar has an internal combustion engine called the F-type. They took the same chassis and body type, and they made that into an electric vehicle. And now they have the chance to basically, determine whether or not they're going to have an Evoque with plain roof or Evoque with sunroof in this case. This gives them incredible flexibility, being able to say, okay, if we do a what if on this feature, that becomes an outcome in terms of cars. It can drive positive or negative revenue impact, and it can also drive positive or negative cost impact. And so we're able to tune the supply chain based on demand, based on revenue, based on cost, and based on availability in ways that we could never before, because we have full visibility from suppliers to cars to delivery to consumers. So Jaguar Land Rover has really transformed how they're interacting with their digital twin of their supply chain. And it has had a tremendous uptake in terms of the profitability. As Harry said in our first slide, adding 100 million pounds of incremental profit, based on what they're able to do in the supply chain is tremendous business value and breakthrough capabilities that they've never had before. So let's talk about let's go a little bit deeper here and talk about on the next slide, the Tiger supply chain solution focus. We really want to increase the accuracy. And we're going to talk about that, in just a second in detail, but the summary is we have humans, algorithms, and we can leverage both machine learning and graph. We can utilize existing technology and we can integrate with SAP or JD Edwards or other legacy platforms. And we can bring that in and we can actually ingest that from the graph. And then we can actually also use that as a way to score our various outcomes. We can decrease false positives in terms of ensuring we have the right answers that can be tuned to humans in the loop. We can increase speed and efficiency. We can adapt to changes, and then we can have continuous improvement over time. And the system can learn, adapt, and get better. So what specifically does that mean in terms of what the combination of graph plus machine learning means? Next slide, please. We can increase accuracy and reduce false positives by over 16%. This is really breakthrough because, as you can see, we can actually leverage a combination of machine learning and deep learning to increase by 5%. We can add graph and machine learning insights and algorithms by another 6%. And then with really superior visualization and by including humans in the loop, we can add another additional 5%. So all of a sudden, we're looking at a system that has depth and breadth and insights we can't get by any other means. So next slide, please. Here's what the architecture looks like when it all comes together. On the left, we have all of our data sources. That could be legacy systems. It could be any data lake, any data warehouse, any database, and any file system. So we can bring that into the graph database. We can run queries and algorithms. We can actually integrate with via Kafka or Spark. Our core capabilities in terms of our storage engine and our processing engine scale out across multiple systems. We can take on petabyte workloads. We can deploy in any infrastructure, and then we can integrate with all the enterprise logic and all the enterprise applications we expect. And we have a very powerful visualization capability that Scott will tell you about after Graham has his discussion. So now I'm going to turn the conversation over to Graham, and he's going to go deep on machine learning and graph and how humans are still essential to this process. Graham, over to you, please.
Thanks, Michael. Great introduction. As Michael said, I'm going to dive into some specifics here and talk about how these things apply under the hood. Before I do, just wanted to make sure that everybody had a chance to poke over to our website to check out the resources that we have on using these technologies in the supply chain space. There's a ton of material over there if you want to jump into the specifics. So this is what we are looking at in terms of the data maturity curve in an organization where we're migrating from the fully offline environment where we're collecting data all the way on the left, making decisions on that data by using our data science teams or our supply chain analysts. And finally, and where we're going to focus today is on that yellow box on the right-hand side there, where we're actually making decisions autonomously using the technology I'll talk about here, and making sure that those autonomous systems always correspond to practical business operations. And as Michael mentioned earlier, that they are getting better over time by interacting with domain expert human operators. So I'm going to, in this little first section here on the next slide, let me show you a couple of different algorithms. These are just the names of, on the left, some graph algorithms, and on the right, some machine learning algorithms that we combine, again, under the hood here to drive these systems that showcase, that power the UI you'll see Scott demo later. And again, if you are interested in the specifics of how to combine these algorithms, just go over to our blog page. We have lots of information on each one of these. So here are the high-level types of graph analysis that we use to power our supply chain application. And we don't have to go through all of these in details, but what you can see here is that there are a number of categories of algorithms that Michael talked about earlier. So we have clustering types of algorithms, those group neighborhoods together based on behavioral consistency. We have things like similarity algorithms to measure performance and behavior against other entities. And we have things that are path-based. We have algorithms that are path-based, so we can understand how and why things are flowing through our supply chain. One level deeper, let me take you to the next slide here, where we show a couple of specific types of algorithm patterns. And what we see as we move across the slide from 1 to 4, left to right, is a set, essentially a workflow, an algorithmic workflow that starts in the linking domain. This is how you understand which of the entities in your supply chain connect together, across a pattern matching behavioral analysis, again, using that graph capability, through then a discovery of commonality. So I mentioned those similarity algorithms earlier. And then, of course, into that community detection system, where we're understanding what behavioral similarities exist between different parts of our supply chain. For instance, in Michael's example earlier, in Evoke, probably has similar constituent components to other products in the Land Rover product line. And of course, we know that's true. They make many different types of cars. And finding those communities and those consistencies between the supply paths that actually deliver each one of those products in a product line is super important to understand how we can adapt over time, how we can change our business practices to let's say, utilize different components from across products in the same product line to increase our margins. One more high level slide here to just talk through the details of how we actually power this system. This is not one particular algorithm. This is fairly typical of many of the algorithms that we will talk through today. And that is starting over by number 1, we take a structured graph-based data structure. In this case, it is the TigerGraph database, which houses this graph structure. We pull a piece out of that structured graph to understand we would call this an ego graph in the graph analytics business, to understand with some component at the center. Again, that could be a finished car. It could be a hybrid component that's built out of a bunch of different constituent products or supplies rather. And then we push that ego graph into our machine learning algorithm in a format that is similar to lots of the analytics you probably have going on in your work today. And the output from that algorithm is the recommendation we surface in the UI that Scott will show you later. I'm going to jump now into 3 different examples of individual algorithms. The first being bottleneck detection. This is a huge one. Everybody on this call knows we need to detect bottlenecks in our network, in our supply chain, because that is the basis of chain fragility. Essentially, if you have one bottleneck one necessary bottleneck go down, you can't actually produce products on the other side of that. And even at the best of times, if you have this bottleneck, there is always some slowdown in efficiency in your network. This is just a little cartoon. Of course, this is the real system. So this is real data representing what you saw in the cartoon on the previous slide. We can't, as human beings, look at this diagram and really understand anything that's going on. Effectively, what we need to do is use an algorithm, a flow-based algorithm, one of those path detection algorithms I mentioned earlier, to make sure that we can autonomously detect those bottlenecks. And once we've set that algorithm up, and I'll talk about this at the end of my section, we can build it in such a way that it ingests in real time from the graph database so that it always surfaces. If there's a slowdown, if there's a bottleneck that pops up, it will be surfaced in the UI. One more slide here on bottleneck detection, and that is this is just a display of a very small piece of a subgraph. and on the top, just a cartoon representation of what the nodes actually mean in that graph. The recommendation here, of course, is to add a second warehouse where you have that bottleneck in the middle of your chain there. That enables a more robust supply chain, robust to failure of, in this case, warehouse one. And also, of course, enables a more efficient flow through from raw materials to delivery of products on the right-hand side. So let me jump over here into another class of problems that we're just going to call predictive analytics, because this covers a big swath of algorithms. The way that this works, of course, in the demand forecasting setting is that we have again, another machine learning system, and this is common practice these days. However, in this case, what's not common practice is that we're consuming graph-based information, like we saw in the previous chapter, into the algorithm for demand forecasting in order to get those behavioral characteristics I mentioned earlier. When we do that, we can more accurately forecast what consumer demand is going to look like, or even downstream demand inside of our supply chain, based on what we know about the pull, the draw on that sort of right-hand side of the network we saw earlier. So let's jump forward. Another piece of predictive analytics, facility grading. So if you have a whole bunch of different facilities, as we all do inside of our supply chains, these actually don't necessarily have to be individual physical facilities. They could be machines inside of a single manufacturing center. They could be human performance across a department. The idea being here is that using that similar system that we looked at on the previous slide, that predictive analytics system, which in this case is a neural network, we're able to score, we're able to grade based on a quantitative rubric that consumes from that graph database the performance and effectiveness of the facilities in this network. And as a last touch point on predictive analytics, I actually put a real output in here. I don't know if there are any data scientists in the audience, but this is the actual TensorFlow network, the neural network that's doing this metrics analysis. So we're ingesting all sorts of information on the left-hand side that is standard, like the average lead time over the past 3 quarters. But we're also ingesting information, of course, about that we could only really efficiently get out of a graph database. Like, for instance, the operational slowness or operational efficiency across the entire path through the chain, getting to the Malta distributor facility in this case. And what we get out is any predictive analytic, right? This is a very similar setting for all of these, but in this case, an output capacity prediction. All right, I want to talk about one last application here, and that is dynamic routing. We've all heard of this. Everybody on the call has heard of dynamic routing. And I'm mentioning it here in the context of actual physical logistics and delivery. However, it's really important to note that this is the exact same algorithm you do use in the routing of material through a supply chain. And those are the metrics that actually drive planning optimization algorithms. So I'll talk through that here and then again in a minute. This again is just a little cartoon look. Of course, if we have a truck driving from Phoenix to DC, if there is a problem in Dallas in your facility there where there's no inventory left, we want to be able to automatically determine that you should route through Austin, because you can pick up your inventory there. You can pick up those goods and get everything shipped. Analogously, if you were trying to make a rough cut plan for your supply chain over the next, let's say, 3 years, what you would do is you would use the same algorithm. So let's say rebalance optimal inventory across the entire delivery chain based on the expected, as we talked about in those demand forecasts earlier, the expected inventory levels at each one of the facilities or each one of the stations and machines inside of your single facility. So let me show you a little UI, what this looks like for real, because we've been looking at a lot of cartoons. This is an actual delivery and logistics algorithm that we built using a system called reinforcement learning. This is the same setting we've talked about, consumes from a graph database, egresses information into our product, We'll show you that. Scott will show you that momentarily. But again, this algorithm that's being used here for delivery and logistics for dynamic routing can also be used for dynamic flow calculations. And those flow calculations, again, like how much continuous inventory to distribute to which places in my chain in real time, and in the future, if you're using a forecasting algorithm, are the things that drive that optimization setting where you say, hey, we think this is going to happen coming up in Q3 next year. And because of this shortage, we're going to need to plan for this and reroute goods through, whatever other country that can service those requests. Diving in for 2 slides here on the details, I'll go real fast over these. If you have questions, feel free to reach out to me. This is the actual logical flow of that machine learning system. So fully decoupled training algorithm with the actual simulation algorithm. The simulator in this case being the thing that verifies whether or not your system is corresponding to actual real reasonable business operations. And both of those decoupled systems are persisting information into 2 different databases. So 2 different graphs. One, in this case, is routes, but again, analogously could be paths through a routing chain. And then the other is the algorithm database. So that's how this sort of logical flow goes. And then one more deep slide here on the actual data flow of the system. So folks in the audience who are technical may be wondering about how to kind of like organize this, how the whole system works in the back end. You can see TigerGraph in the middle there consuming from a streaming ETL job. There is an offline training algorithm, which can be triggered automatically. And I'll talk about that momentarily. And then there is on the bottom part of this slide, the actual real-time inference engine. So this is reading again from another topic, another streaming system, and making decisions and recommendations in real time and serving those up to the UI Scott will show you momentarily. Before I wrap up, I just want to kind of summarize here with one high-level slide talking about what you can do to understand why these systems are making the decisions they're making. In many cases, using a graph and using machine learning can seem daunting because they can appear to be black box. That's the perception some folks have. But I would actually argue that it has the opposite effect. So using a graph structured data set, you actually have better visibility into why things are going on, as long as you have a system like the one we'll show you here in a minute that allows users to dig into those details. And secondarily, leveraging some of the advances that have occurred in the last 3 years in explainable AI, we're actually able to use that graph information and that machine learning information together to tell users, to explain to users why that system is making the recommendations it's making. And you will see some of that in one moment after I turn it over to Scott. Thanks.
Thanks, Grant. I think, if everybody's still following along here, that was pretty heady, right? Graph, machine learning, how we do some of the analytics that we've always done, but do them in a different way. That's pretty sophisticated. But what we're about to see now is it doesn't have to be complicated for the rest of the group, right? So there are things that we need to use the power to get to. And I think that's what we see in our first slide here is our friend, if you haven't seen it, I invite you to go to the TigerGraph website. There is getting started, and then there are some what we call starter kits. There are some of those that are out there. And what that's going to show you then is what do you do inside of the TigerGraph database. So TigerGraph, again, is market leading a graph data structure, and you have the ability to write queries in something called GSQL. That console is primarily designed for IT, machine learning, and developers. Extremely flexible, fantastic interface. What I'm going to talk about now is the other half of the equation. So everything Graham just talked to you about, that's the interface that you would use down there at the bottom is the TigerGraph Studio. But what about the rest of the organization? Not everybody is going to see a dashboard where they see supply, demand, S&OP, capacity planning, et cetera, they're not going to see that code or write that, right? They want to see certain things that have been curated, this idea of alerting, this idea of investigation, the idea of how do we start to look at cues and numbers and process and those kinds of things. And that's where we're going to go now, is how do we create, the buzzword of the month is explainable machine learning or explainable AI. And that's really what the rest of the picture. Now, that's something also very unique about TigerGraph. In the pictogram that Michael showed us was there is the database and there is the functionality that I'm about to show you, which allows now for us to help you, prospects and customers, start from that ground zero with just a graph database, but the ability to do something more. So the modules are pre-connected to TigerGraph to allow you to get a jump start. Now, what are those modules? We have multiple here. We don't have to go through all of them, but the point of this is that ability to explore data, show analytics, right? Be able to find rules or triggers or alerts, be able to find now whatever these anomalies are in our supply chain or capacity or planning or whatever they may be. And then finally, we have some support capabilities down below for your organization. And the point of this supply chain module is to do both, is to allow you, if you're using SAP or JD Edwards, bolt on to what you already have. You don't have to buy all these modules. These modules are all optional. But what we're finding is everybody enjoys a good graph database, but we're not doing it for fun. We're actually out trying to solve one of those previous use cases that Michael and Graham sort of pointed out. And that's really what we want to do now. How do we do that? Now we start to see those screens that Graham talked about, but we put it now in a very simplistic way. We start to see those same things that Michael pointed out about how to solve things in real time, visualize those deep link patterns, and then give the human a chance to either make a decision, right? So they doesn't have to be determined automatically. The human can actually teach the system. And that was that other path curve that we saw Michael show us, was not just the act of the math that Graham showed us, but it was the combination of the math plus the graph, plus the human now being able to see where is the bottleneck. I have seen it and I have decided that I would like to make a change and or alter it. Perhaps there are more or similar paths that we can do. And in this kind of a workbench, if you will, we have that ability to draw the human in, show them where things are good, show them where things are bad. And then in this vignette here, and we'll see this here in a minute, we have the ability to look for capacity or flow items. And with simple iconography in colors and treatments that we're all used to, it now allows me to dig in and see where in that connected data those things are occurring. And that is really sort of the kicker, if you will, is not just solve it, but be able to allow a human to understand it and intervene. That's where we get that maximum percentage of increasing the accuracy and doing it at speed and a velocity that's important to the business. We can also do things like forecasting, right? So as Graham mentioned, there are ways to look at what if scenarios, right? I can drop in different things. A graph is incredibly capable of walking hundreds and hundreds of permutations in milliseconds in memory. Why? Because graph databases actually connect the relationships and they can be multidimensional. So as Graham mentioned, and also Michael showed in that Jaguar Land Rover, there are these, as I call it, the Rubik's Cube or the multiple planes. You may have multiple parts, you may have locations, you may have source materials, etc. Those are graphs within graphs, and connecting those is something, again, that a TigerGraph is very, very good at. But if you put all that together in a picture, it can very easily overcome a human being. What they need to see is discrete portions of that. They need to see where that forecasted outcome is and be able to demonstrably touch and own what these what if scenarios look like so that they can then make deterministic outcomes, right? And that's the beauty of this, is it has that ability now to do the back end where the heavy lifting happens and then be able to show the visualization in how you do that. The other thing that we can do now is this sort of massive set of what ifs. How do I smooth the curve, right? If I have hundreds and thousands and millions of SKUs, I may have multiple regions. I may have to do all of that. In order to do that kind of a what if or optimization, it's very, very daunting, right? Can I get it all right? No, right? But I can get a majority of what I'm looking for, and I can solve on key what we call dominant dimensions. It could be time, it could be location, it could be price, it could be my end customer, right? It could be the cost of the goods, or perhaps other kinds of things. And that's the beauty of a graph database, is that flexibility for the back end to be malleable, right? So the other thing about a graph database is you can change it underneath the covers and it doesn't break the way a data mart or some of the other kinds of 40 table outer joins, as we've all seen in a SQL world. But again, the point here is to bolt on to what you already have. So work with an SAP. It's not designed to replace it, et cetera. But something like this kind of a screen now can allow those users to really weigh in. Okay. So with that, what I'm going to do is I'm going to switch over and show a live demo. In our first vignette, what we mentioned was the dominant dimension of time. We also mentioned some of the concepts of risk, right? In this first layout, we see a dashboard. Well, many of you today use Tableau or Power BI or Looker or your favorite dashboard tool. Again, we're not showing the dashboard here to say, let's replace the dashboard. These are designed as widgets, but this is now, as we start to step into this, we can start to see information in a different way. Now we can see our friend time on the bottom. We can start to see where things change. And again, a graph is very responsive. So I can actually select this. Now what I'm starting to do in that example that Graham showed, that bottleneck detection, I can start to see things changing. I can also look at data across different phases. I can see color coding now that says, well, I may have some bottlenecks in my source area and my compliance area, et cetera. Now in this diagram down on the bottom, we can start to do our first sort of true graph interaction. Risk can sometimes be, as Graham showed us, more complicated than just simply ranking things in a simple numbering. There may be weights, there may be lots of deep links and those kinds of things. What this allows us to do now is connect with a TigerGraph, and then allows us to say, well, maybe that inventory shortage is higher in its risk capability. Maybe I don't need to care about supplier confidence and so on. What I'm able to do now is respread that in real time. Now what I can do is I can actually create those risks, find out sort of where those bottlenecks are. The other thing that we can do inside of a graph database, and again, you see lots of charts, those kinds of things, and those can come from those other areas, but we can start to make deterministic outcomes or recommendations. As Graham pointed out, if I do these kinds of things down here in operations, I can save money. I can actually make money or avoid losses, right? And that's really where the graph is starting to stand tall. Now that I've sort of identified perhaps where one of these areas might be, I see that I need some inventory and I may not have enough resources to cover that. I need to dig in one layer deeper. What I can start to see now is in my time frame here, I see my different products. And if we remember back to that three-dimensional chart that Michael showed, which is I may have 3 separate graphs. I may have something which is my bill of materials, so I may need to get source parts right. And I see that now down here that I'm being told about. Then I may see there are areas where those things get assembled, right? That's yellow. And then maybe there's a compliance step that's red. And what I need to do now is I need to go find that bottleneck in detail. And it's a set of dominoes, right? As we saw in that diagram, which is if I move too many parts to one location, I may break things that were perfectly fine. Right? I may need to go do a deeper level. So in this screen, this planner is able to go look at the connected data, and we see it across here, which is the bill of materials. I have this product. Now it's red for that time period. What I'm now realizing is there are multiple parts that make up that bill of material. And this is our typical view of a graph, which is what we call the ball and the stick. And sometimes this is all we see in a graph. But the beauty of what I'm about to show you is in the user interface that comes with TigerGraph, it doesn't always have to be this view. Some people like to see this. So in this case, now what I can do is I can add this particular part, and I can say, I'd like to see how that part and this part and perhaps this part over here are all interconnected, right? Now, I can see how they look at it in the bill of materials, but I want to know more. The other graph is the location. Now, in this case, what I can see is I see different locations, right? I can start to see these time frames, right? I can see where these different locations are, et cetera. And just because I have my parts, and I get them all there on time. It doesn't mean that in this case, this distribution center down here in October, I want to see what that potential impact is, and I want to see how those parts relate to the location. The third one that I want to see is, just because I have the location ready doesn't mean that all the parts are ready. And if the parts are ready, that doesn't mean that a human or an assembly line machine is ready to accept those. Those are the three different dimensions. And what we typically see in a lot of our prospects, as we did at Jaguar Land Rover, was you can solve that Rubik's Cube, as I call it, for one color and say, I got it all right. But then you flip over to the other side, and sure enough, you still have a bottleneck. That, again, is sort of the power of what we're doing with the graph. So what I can do now is I can add that as well to this vignette. Now what I've seen is I've found a series of these different objects that are over here. And again, they could be parts or pieces. And what I can do now is I can actually go through and double click on these. And by simply connecting what these elements are doing and where they are, I can start to see now their interconnection with each other. So when we look at this bottleneck now, I can actually start to really parse out where these things are connecting. Now I can group these or color these as I see fit. But what I can start to do now is, in red, I can actually denoise this. I can say, well, you know, I don't care so much about where we are in the process or what that phase is, right? What I can really get down to is there is a location in Houston where these parts and pieces are coming, and these bill of materials that is the crux of my bottleneck. And as we saw in Graham's diagram, these kinds of things can be sent to my dashboard automatically, or I can have a third level analyst, as we saw here, dig in and find out. So that is our vignette number one. So that's that one idea that Graham showed us for bottleneck, and sort of how do we do that in TigerGraph, and then how do we do that in Tiger supply chain. This is sort of vignette number one. Now the second one that we see is that concept of I have thousands of SKUs, and what I see now is I have this what if capability. What I can see over on the left is I have thousands of different parts and pieces, and over here on the right, I can see that if I want to individually show what those are, or perhaps I want to look at all of these parts and pieces that are on the screen, and I can see that they're under capacity. The beauty of a graph is I can actually run this now, and what I can do is I can run this in the background, and I can start to move the dial, right? I can individually start to change these. I can look for those things, and I can say, well, I didn't do that very well, right? So what I can do now is I can rebalance and continue through this what if capability here to go find those things, et cetera. The other thing that I can do is I can actually switch over and I can go look at different kinds of products inside of the application here to see where they're going in the process. And that's the next thing that I can do over here. Now what I can do is I can say, well, I'd like to come look at a product, and I'd like to see from a source all the way out to the customer, where are those additional sort of follow-throughs on that. And what I can do now is I can show this flow chart where I can go basically back and forth here, and I can see, now I can see my friend here, the node chart, to go do that, right? And what I want to do now in this sort of diagram is I want to sort of go back and forth with this. Now what I can do is I can say, okay, I see where the bottleneck is. Now I can zoom in and see where those nodes are, et cetera. Then I can switch back over to the nodes here. And then I can say, well, it looks like some of my source material folks are good and some are bad. So in this case now, what I want to do is level out that sort of pinch point, if you will. Then what I can start to do is, as I'm walking through this now, I can come in and I can say, okay, where are they? Where am I going? And then as this sort of walks through here, I can then look at it in a different way. I can see my node connection here. I can see where that is inside of this, et cetera. And so what I can do now is I can zoom in a tad more. I can co-visualize this. So I can see that now I've got items in a distribution center. Those are green. What I now need to do is move those to another. So instead of making or buying more, now what I can do is I can do that what if module to be able to get me out of that. And so I think where we're going now is these kinds of visualizations. These are all samples of what we can do. The toolkit that we mentioned here has the ability to change colors to make it look like your Tableau dashboard or your SAP kinds of looks and feels, et cetera. And that's really what we want to do, is that capability now to fit your environment. Now, all of that bringing together, why are we here to talk about a graph database? Well, one of those is this capability, as Jaguar learned, was this ability to take huge sets of data, this deep link to show not just all of the SKUs, but all of the SKUs in that dimension, where that 6mm screw may sit in every part in Jaguar Land Rover, right? That is an enormous deep link discovery pattern. To be able to do that with 10 years of data is an enormous problem, right? So you must have a data structure and or a graph database that has that ability to do it. Then Graham mentioned how we actually are able to use that in graph analytics, work outside in machine learning, and then bring it back into the graph, right? To be able to have those kinds of things at hand are core, especially at the size and the scale for what we're looking to do. The next one then is this ability now to take that democratization, right? So allowing the users to use the screens that I showed, allowing somebody to use now the detail of the machine learning or developers, right? Bring it all together in one place. And that's really what that whole ecosystem that we started today's webinar with, is that ability to show how they all fit together with one platform. And that includes the TigerGraph database, and then also now the Tiger supply chain solution that I would give just a small demo of today, is to bring it all together. That's when the capabilities happen. Now, how do we do that, right? We have the ability now to bring that data together, bring the machine learning together, bring those humans together in that curve that Michael showed us, right? To get that big bump out of what we're doing. And again, all we have to do is bolt this in. We don't have to rip and replace like so many systems, and weeks are the timeframes that we're looking for these kinds of increases in information, as well as planning and those kinds of things. So with that, brings us to a close, right? What we want to be able to do now is say that we can do this at scale, at speed, in the cloud or on premise. And that's really what our goal now is to bring this entire capability to you. So if you do have questions now, we'll be open for those. And with that, back to you, Laura.
Great. Yeah, thank you all so much. These were great presentations. Just as a reminder, we do have a few minutes here for Q&A. So if you have any questions, definitely feel free to drop them in the Q&A box or in the chat. I'll go ahead and get started. There were a few that came through during the talks. Michael, we had one for you. How can we get started with TigerGraph?
Great question. Thank you, Laura. So basically, the simple answer is that we have a free tier on TigerGraph Cloud, 50 gigabytes of data, and you can get started by playing with that. We also have a version of the toolkit ready to go on some of the clouds, and so we'll be able to work with customers to get started on a proof of concept, leveraging the combination of some of the things Scott shared with you and showed, what Graham was talking about, and what I shared as well. So we have a way to work with customers and partners directly to deliver this capability. So get started on the cloud.
Great. Thank you so much, Michael. And Graham, one did come through for you as well. It's a two-parter, but can these algorithms work for material flow? And what kinds of data do I need in SAP to get started?
Yes, the algorithms I mentioned can be used for material flow. And I tried to make an analogy about how that was similar to dynamic routing when I was talking through that stuff. And to get into the details, just reach out and we can talk through everything. The data that you need to get started is the same, essentially everything you're using in SAP. So if you have material manifests and timing on deliveries, or even better is like expected shipments and forecasts, those are the data types that we use in our algorithms to do that material flow and optimization.
Cool. Thank you so much. And then Scott, we had a final question for you. How do the visuals connect with TigerGraph and other supply chain systems we use internally?
Great question. One of the things that we can do then is connect to, so TigerGraph comes with a couple of different metaphors, if you will. REST is one of the first ones. The second one then is JSON, and we can do other kinds of things. But one of the things that's unique about the visuals that I showed today, is that they can not only connect to TigerGraph, but also natively connect to an SAP or a JD Edwards. So what you can get then is what we call a predicate, where I could look up a part, leave some of that information inside of SAP, query the graph database as Graham had showed us, right, and then create that in one singular visual interface, et cetera. And so the beauty of that now is you can allow a dashboard or a single interface for all of those. And so that's very easy to do. And as Graham mentioned, as we sort of talk to each of you individually, if you have those sort of capabilities, we can talk about how we can do that.
Okay, and then there was one that just came through the Q&A. What about the stores? If they are not connected to the system, is there a warning that it is not connected?
Graham, you can take a swat at that.
Yes, indeed. We can set up all those triggers. Whatever type of system you're using for monitoring today, we can plumb in a trigger there to build an alert. If you don't have any systems in place today, then of course there is a flag you can populate inside of the UI you saw, and all of the monitoring, both like hardware monitoring and the logical monitoring of the algorithms and the system itself, can be output to essentially any file format that you wish. Scott just mentioned a quick REST interface for outputting JSON. That's an obvious one, but it works for anything anything you wish.